I'm going to say from the beginning here, the numbers in these problems aren't particularly excellent, and so it's totally reasonable for you to be here with a calculator. If it were me, would not be trying to sit here doing that long division with that. It's all ugly. So I am telling you right now, a lot of this stuff is going to be done with a calculator. And that's fine. That's totally cool. Calculators are tools to help us, and it's okay for us to use them in situations where the whole point isn't like trying to figure out what the answer is by hand. Like if part of the problem, part of the thing that I'm trying to assess from you is, can you do 2 to 3 digit long division with decimals? Then you wouldn't be able to use a calculator, but I'm not checking that. So the whole point is, remember, triangle area equals 1/2 base times height. So I've got the area is 17.9 equals 1/2 of 9.4 times the thing we want to find, right? The height. So, however you want to combine these, you could say, all right, well, let's multiply the 2 over to the other side and then divide by the 9.4. You could totally do that. Or you could say, well, what's half of 9.4? And divide that into 17.9. Both of them are going to give you the same answer. I'm going to say, what's half of 9.4? Well, half of 9 is 4.5. Half of 0.4 is 0.2. So we got 4.7 x. So now we're going to do 17.9 divided by 4.7. And I'm just sitting here doing it on my calculator here in the background, so it's not cluttering up the page. And if we look, we end up with x equals 3.80851068. It's a number that's ugly, and we don't want to have to deal with it. So I have not specifically given you a place to round to. And remember, in this class, if I don't give you that specific information, 4 decimal places. So 1, 2, 3, 4. Draw the line after the 4th decimal place. Next thing's a 1, so that's too small. And so our final answer is 3.8085. And then the units, if we look here, miles, so we're going to do miles. Right? Same thing with this one. Exact same problem, just new numbers, right? Area equals 1/2 base times height. Well, what's the length of the base? We don't know. What's the height? 4.1. So we're going to do 1/2 of 4.1 x, right? Because it's all multiplied together. Well, what's half of 4.1? Well, what's the area? I didn't even put the area. See, that's the important thing. You got to plug in for everything that you're missing. Right? There we go. Now, what's half of 4.1? It's 2.05. So we got 12.5 equals 2.05x. And then again, all we're going to do is we're going to divide the 2.05 over. And what are we going to get? We're going to get 12.5 divided by 2.05. And our answer here is going to be 6.09756. Got to make more room. 0.976. And then again, I round to 4 decimal places. So I look here, draw the line between. This is a 6. That's too big, so this is going to round up. And that was a 5, so now it's a 6. And what are my units? Inches, inches squared, so I'm going to put inches right here because it's a length of distance that we're talking about. Same idea with the parallelograms here. Remember, the area is base times height. So that's 84 equals 12x. I think this one actually goes in pretty evenly. Well, when I divide, so I end up with 84 over 12 for sure. And if I divide the top and the bottom by 6, I know they both have a 6. 84 is, I think it's 14, right? 6 times 14 is 84. 6 times 10 is 60. 6 times 12 is 72. 84, yeah. So I can actually simplify this more. So this is actually x equals 7, right? And what are the units? Inches, inches squared. So I'm putting inches here, right? Last one, we got 48.5 and 5. So again, area equals base times height since we're working with a parallelogram. 48.5 equals base times height. And we can actually probably do this in our head, but I don't want to. 48.5. Ooh, not typing into the right spot, am I? Let's try that again. 48.5 divided by 5. Yeah, comes out pretty nice and even, which is nice. 9.7. Exactly 9.7. I want the pen tool. There we go. So we can end up with x equals 9.7 exactly. Like I don't have to do any rounding because this is already that number. And we've got feet and feet, so it's 9.7 feet as our final answer here. Alrighty, so that's that. Just sort of reviewing the ideas from yesterday and the day before, from Monday for us. So let's get into what we're talking about today. Finding the area of a rhombus, a kite, and a trapezoid. So it's basically just going to be the same idea as what we did last time. You know, attend to the area formula. Make sure we have the right measurements in the right spot, especially for the trapezoid. It matters where we put things a lot more. And then just do your math. So let's go ahead and start. With the trapezoid, we've got and they write it weird. 1/2 times height times the sum of the bases. I don't like it written like that because I don't think it makes as much sense. See, because what a trapezoid is, imagine for a moment if we took this side and cut it down the middle. We took this side and we cut it down the middle. And we swung this up. And we swung this up. We get a rectangle. That's what a trapezoid is. It's just a rectangle that's a little bit melted, you know. And so what ends up happening here is when you do your base times height formula, in order to figure out what that is, it's just the average of this base and this base. Because, it basically half of this is going over here, half of this is going over here. You're averaging it out. So when you're doing the area of a trapezoid, think of it like this. Because that's what you're really doing. That's what you're really doing, right? Remember, the average is you add them up and then divide by the number of things that you added up, right? So average of the bases, right? Times the height. Now, the way that they wrote it is fine. If this is how you remember it and this is how you want to remember it, that's cool. But I'm telling you right now, this way of thinking about it requires a whole heck of a lot less effort. It's a lot less to remember because you have context, and so you don't have to rely on like just rote memorization. You can use the context of what you know to make this easier to deal with. That's the way I remember it, and it makes it a lot easier for me. And I'm speaking on behalf of myself. All right. But that's sort of how I would do it if it was me. All right. So let's do some problems. So here's a problem. Basically, they're going under the assumption that the state of Nevada is roughly trapezoid. So we're going to go through. We've got the average of the bases times the height. Well, let's average out the bases. That's 716. So that when we average this out, we get 358. So that's the average. So 358 times the height here, which is 309. So we've got 9 times 8 is 72. 9 times 5 is 45, plus 7 is 52. 9 times 3 is 27, plus 5 is 33. This is a 0, so we don't have to worry about that. Now we're going to do the hundreds. So 2 zeros down here. 3 times 8 is 24. 3 times 5 is 15, plus 2 is 17. 3 times 3 is 9, plus 1 is 10. Sorry, I'm tilted here. And this is our final answer. That many. So area equals 110,722. And what is our unit? Miles squared. Alrighty, so let's go over this one. Same idea. They just, it's more vanilla, right? They didn't have a whole picture of Nevada in the picture. So draw out your trapezoid. Don't try and do this in your head. I'm telling you, it's so much easier to not do it in your head. Right? Here's the height is 7. This base is 12. This base is 15. What's the average of the bases? Just realized, did I? No, I did it right. Okay. What's the average of the bases of 12 and 15? 27 divided by 2. I mean, you could say 13.5 or 27 over 2. Either way is fine by me. And then you're going to go ahead and you're going to multiply that by the height. Then you're going to do that out. 7 times 5 is 35. 7 times 3 is 21, plus 3 is 24. 7 times 1 is 7, plus 2 is 9. We count one decimal place. 94.5, and what's our units? Centimeters squared. Because we're dealing with an area. All right, and that's all there is to it. Once again, how you sort of attend to this is totally fine by me. if you're working with a trapezoid, you want to write it out like this, plug the numbers in and then just crunch it out, you can. If you want to do it like what I did, where I just found the average of the two bases and then multiplied it by the height, that works just the same and just fine. All right? Next problem. All right, so we want to find the area of this trapezoid. Now here, they don't give us the height, so we're going to have to find the height. We're going to have to remember that this is a 30, 60, 90 triangle right here. That's the key. Well, this piece is 5, so this piece over here is 5, which means out of 7, this piece is 2, right? Now, if you remember your 30, 60, 90 triangles, from here to here, around the 90-degree angle, you times by radical 3. So this is 2 radical 3. If we were going the other way, we'd divide, but we're going from small to big, so we're multiplying. Here's our height. So now let's do our problem. Well, average of the bases, average of 5 and 7 is 6, right? So times the height, average of the bases times the height, 6 times 2 radical 3 is 12 radical 3. All right. So the thing that makes this different and difficult is you've got to go back and you've got to remember your 30, 60, 90s, right? We talked about those. If you are concerned, if you're not sure about what's going on, make sure to go back and rewatch the lesson I did on 45, 45, 90 triangles and 30, 60, 90 triangles earlier this quarter. All right. Make sure to double check it on my YouTube. I'll see if I can't put I'll try and put a card right here if I figure out how to do that. Because I've never done that before, but I'll try and figure that out. All right. Now it's your turn. So again, basically they're describing it's the same trapezoid, but now the angle is not a 60-degree anymore. So draw a new picture, make it a different angle, and give it a try. All right? Alrighty. So once again, it'll help if you draw your picture. So here we had 5 and 7 on the bottom. Actually, let me draw a better picture because specifically this is a trapezoid with a right angle right here. So this is 5. This whole thing is 7. And this piece is a 45-degree angle, right? So that's 5. This is 2. This is also 2. Remember, 45, 45, 90 triangles, the two legs are the same, right? So that's all. Now we're gonna go ahead and we're going to do our area. Once again, trapezoid. Average of the bases, just like it was before, is 6. But now the height, instead of being 2 radical 3 like it was last time, now it's 2. And the units are still the same. They were meters squared over here. So they're still meters squared over here. Alrighty. So I think that covers our trapezoids. So a couple things I want to talk. So first of all, this is a formula that we're going to be able to use. Find what the diagonal lengths are, multiply those together and divide by 2. I want to point out for a kite, that's the one that works. For a rhombus, remember a rhombus is also a parallelogram. So with a rhombus, you have lots and lots and lots and lots of options. You could still do base times height for a rhombus. But if they give you the diagonals, then use that one instead. All right. So 1/2 times the diagonal times the other diagonal. And when they say the diagonal, They expect corner to corner, all the way through. If you don't use all the way through, you know you ain't right. So make sure you are using the entire diagonal when you're doing this. All right. So we want to find the area of this kite. So what we want is we want the diagonals, right? Well, let's look at what we have here. They give us the little pieces, but we don't want the little pieces. We want the entire thing from K to M and the entire thing from L to N. So all the way through here, we've got 2 and we got 5. So this first diagonal is 7. Same thing here. We look here. We've got 3 and 3 from L to N. So this second diagonal is 6. So now all I'm going to do, 1/2 times the product of the diagonals. So let's plug that in. 1/2 of 7 times 6. We go through, well, what's 7 times 6? That's 42 divided by 2 is 21. And what's our units? Again, you see meters everywhere, so we better be working meters squared for area. So once again, we've got the diagonals of the kite. They give it to us, and we're going to have to find the area. All right. So once again, here, I don't even think you need to draw a picture. They just give you the diagonal straight off, right? So just 1/2 times these two diagonals. What's 1/2 of 12 is 6 times 9 is 54. And notice we're working in inches, so inches squared. Don't overthink these. Don't overthink these. All right, last ones. We did some kites. Now let's do some rhombuses. Now they give you this whole spiel about carpooling, but here's the picture, right? We need to know the diagonals. Well, they give you this little piece right here. And if you remember from chapter 6, the diagonals are symmetrical. So if this is 2.5, this is 2.5. So what we have to do now is we have to figure out this diagonal. Luckily, we've got a right triangle, so we can use the Pythagorean theorem. If we do 6.5 squared, I believe it's like 42.25. I think. I'm going to calculator town real quick. Hey, I was right. It happens so rarely. I like to celebrate myself when it actually does happen. So 42.25 equals x squared plus 625. Subtract that over. So x equals, we don't care about the negative version of the answer because we're dealing with length. So this is 6 feet, right? Which means that's 6 feet. Well, okay, so now I'm going to do my area. The first diagonal, we got 6 and 6, that's 12. The second one, you got 2.5 and 2.5, that's 5. Well, 1/2 of 12 is 6, times 5 is 30. And we look at its feet and its feet, so we got feet squared. So whenever they don't give you all the things that you need, especially when they give you a rhombus, Pythagorean theorem is your friend. And remember, if you've got a piece, you can get the whole thing by just times 2 because the pieces are the same. Does anyone need more time with this one? All right. Then we got this last thing right here. Rhombus has sides that are 10 centimeters long. If a longer diagonal is 16 centimeters, what's the area of the rhombus? All righty. So let's look at what they give us. I tried to give you some little thing here, but they say that the rhombus has sides that are 10 centimeters, and the longer piece, the diagonal here, the longer diagonal is 16, which means that this is 8, right? Well, again, Pythagorean theorem, if we want to figure out this piece so that we can use all our diagonals, we know that, right? Plus 64 equals 100. Subtract over. We got x equals 6 here. So that's a 6, that's a 6, this is an 8, this is an 8. So our diagonals are 16 and 12, right? Well, now let's multiply that out. We got half of 16. We've got half of 16. Multiply that out. 8 times 12. And then what do we got? Centimeters here. So we got centimeters squared. Final answer.